In this video, we're asked to decompose this fraction using partial fraction decomposition. And in particular, I did the first step just to give you an idea of if you're asked in the 9.4 quiz, you could be asked to find the value of A and find the value of B with the decomposition already started for you. This is just to make sure everybody's on the same page. So this is one way that you could potentially see a partial fraction problem come up on our future quizzes. So normally we would have started with just this, and then we would have had to write this. But in this problem, the first step has already been done for us, so let's continue with the second step. Once you've set up the equivalent fraction where you have A over the first term plus B over the second term in the original fraction's denominator, then we want to clear all the denominators. So to clear the denominator on this side, we would multiply by x plus 3 times x plus 5. What's done on one side of the expression must be done on the other, so this entire expression also gets multiplied by x plus 3 times x plus 5. On the left side, this cancels out completely, and we're just left with 4x plus 3 equals, and here both these terms are going to multiply throughout, so we would get the right side is equal to. Distributing this term to both fractions, we would get a times x plus 3 times x plus 5 all over x plus 3 plus b times x plus 3 times x plus 5 all over x plus 5. And here we see that the repeated terms cancel. So this would simplify to this. Now if we distribute and simplify the right side, so let's distribute and gather like terms in our next step. Distributing throughout, we would get this. And now we'd like to group the like terms. We see we have an AX and a BX. Let's group that. And then we have a 5A and a 3B. We'll group that in our next step. Now that we've grouped these terms, we have one final step. Since an X is common to both of these terms, we could, just from this term, factor out an X, which would give an A plus B all times X. And here we see a pattern. Notice that the number that was being multiplied by the X on this side and the A plus B, this is the only term on the right side that involves an X. So for these two equations to be equal, it must be the case that this 4 is equal to whatever A plus B is as a sum. So we could write one equation, because these two sides are equal, this gives us that 4 must be equal to A plus B. And if A and B are numbers, then definitely 5A plus 3B is a number. And this is the only single numerical value on the right side. And because the whole expressions are equal, it must be equal to the numerical value 3 from the left. So we get these two equations, 3 equals 5A plus 3B. Once we solve the systems of linear equations, we'll have the whole problem solved. Let's take a moment to solve these equations. Here, it might be efficient to subtract a b from both sides, and we can use the substitution method for solving the systems of equations. So we have 4 minus b is a, and we're going to substitute that into the a in the other expression. So we have 3 equals 5 times 4 minus b plus 3b. We're going to distribute and solve, so we get 3 equals 20 minus 5b plus 3b. And we would get the simplified equation as 3 equals 20 minus 2b. Solving now for b, we get negative 17 equals negative 2b. We find that b equals 17 divided by 2, or equivalently 8.5. Now let's find the value of a. Substituting in our value of b to one of our first equations, we now just solve for a by subtracting 8.5 from both sides. We get that a equals negative 4.5, b equals 8.5. Going back to the final problem, we now have the value of a and b that we can substitute for, and we find this is the partial fraction decomposition of the original expression.